Hey everybody, this is a quick partial pressure example of one of the problems on our study guide. So this is if I place 3 moles of N2, 4 moles of O2 in a 35-liter container at a temperature of 25 degrees Celsius, what will the pressure of the resulting mixture of gases be? I'm going to do that, and I'm also going to answer the question, what are the partial pressures of nitrogen and oxygen? So the first thing that I do is I want to deal in moles. So I have N2, 3 moles of that. I have O2, 4 moles. So the total moles I'm dealing with here is 7 moles. Once I have the total moles, I can go ahead and use my ideal gas law. PV equals nRT, and I can plug that in. I don't have my pressure of my total, so that is my P total, right? I don't know that. I do have the volume. My volume is 35 liters. I do have moles. I just found that, 7 moles. I have the temperature. It's 25 degrees Celsius. I know that Kelvin equals 25 degrees Celsius plus 273. So that is 298 Kelvin. And I'm going to use, I want my pressure to be in atmospheres, so I'm going to use 0.082. And that is, I'm running out of a little room. Let me see if I can move this over a little bit. And this is liters, atmospheres over Kelvin, moles. Okay, so that's it. So I solve for P total. Divide this side by 35 liters. This side by 35 liters. I can cancel out liters, liters. I can cancel out moles, moles. I can cancel out Kelvin, Kelvin. I'm going to have atmospheres left, which works. My P total will be in atmospheres. And I get out my calculator. And I go ahead and do this. 7 times 298 times 0.082. And all of that divided by 35, and I get 4.9 atmospheres. That's my total. That's my total, my P total. Okay? Now I also know that P total equals my P1 plus my P2, right? So this is 4.9 atmospheres is my P total. Well, what's P1? Well, to find that, I just take a simple ratio, right? If this is N2, if my P1's N2, P2 is O2, I just take a simple ratio. The ratio, or the percent of N2, is 3 over 7, right? And that's just under 50%. So I just do a quick ratio. I go 3 over 7, and that ratio is moles of N over total moles. And I take that times 4.9. That will give me how many of those total 4.9 are nitrogen. And then I add that to oxygen, which the ratio of oxygen is 4 over 7. 4 moles of oxygen over 7 total moles. And that's by 4.9 atmospheres. So let's see if that works. Let's just check ours. 3 divided by 7 times 4.9 2.1 atmospheres. And again, remember, this is atmospheres of N2. Let's try this one. 4 divided by 7, and that's times 4.9, and I get 2.8 atmospheres of oxygen. So does that work out? 2.8 plus 2.1, I think you can see it, is 4.9. So there we go. That's the total pressure of the resulting mixture of gases is 4.9 atmospheres. And then the partial pressures of nitrogen, 2.1, and of oxygen, 2.8. There you go.